Hey, what's up guys? Welcome back to another stream. So today, this is intelligence maxing day 57. It's called variational autoencoders stuff because one of our classes, there's an extra credit assignment that got released and I tanked on the midterm, so gonna need to do this in order to get some points back. But pretty much it seems like all we have to do is create a variational autoencoder. I'm not entirely sure what it does. We were talking about it in class 2 days ago, but there's some complex mathematics and a lot of Bayesian statistics that I don't fully understand. I might spend some time going through the theory behind it, but maybe I could do that along with this notebook here. This is our extra credit assignment. I think what I'm going to do is try to get started. I was able to create the first step here, which is just defining the encoder block of our network. Really, I think what it is, it just encodes our block using some convolutional layers and also ReLU activations. What we're actually training on is the MNIST dataset. So MNIST, I think, is just a dataset full of numbers. And I think what our goal is here eventually is maybe to generate new numbers. I'm not entirely sure. I think variational autoencoders are commonly used in generation task. So it's creating new things based on some type of input, and I think we call our inputs some type of vector that exists in what's called a latent space. Latent space, just a fancy term for some type of vector space. Vector space, I think, is just a fancy term for just some region or a collection or a point in this big ass data space. Alright, so we got...
Unix has cron tab.
Okay, so I was working on this. I'm getting an error right now with the matrix multiplication. I think some of the dimensions are not aligned, so I need to figure out what's going on here. Okay, order, move to bottom. Alright, so I think it's this step. Alright, let me see. So, let's see what x flattened looks like. X flattened.
Just try running it again because it just gave you different results.
Okay, so this is a size of 802,000. Okay.
Wait, I'm just telling you, you need to run a different line.
So we have to somehow, this is our batch size, and C is equal to capacity. Our capacity in this case is 64. All right. Let me try to get the dimensions here. So this should be, we have our batch size by our capacity by 14 by 14, right?
I just texted you this morning.
Okay, so this is going to be by 7 by 7.
Like, come on, name one time you've seen me code.
Alright, so as in features, we have number of channels times 7 times 2, and
He was massively inflating when he said, I pinged the server. Yeah. Like, that was stupid. Like, I don't know why he said that shit. Also, the thing that's such a L is I have to have the tab open.
so I'm wondering how do
He
we.
said it doesn't work in the background.
Wait a minute.
It's stupid. Can you stop hating? No, I was so impressed with it. I was like, holy shit.
How are we getting that? So
He's just a
128
developer,
times 7 times 7, 6,200.
He's not on the go to you. So as a developer, I thought he would actually know how to do it. He just knows how to use Google tools.
Right, so this is 6,700. 6,072. Why do we multiply it by 2 here? And our lay-in dimension is also, I think, 2, right?
How do you have that?
Alright, well, let's try this.
Yeah, but it's like something scary.
Batch size. I wonder if we could do that.
I did this right now because I felt bad for him because the thing is gonna happen for like live for open.
Okay. X mu. Okay, so why is this happening twice here? So I think we could do train test is equal to. So inputs label is equal to image, and then we'll do encoder and input. Yeah, it makes more sense. Okay, so surprisingly, it's running it twice. What if we input high? Let's just try this. Alright, still getting the same error. I'm not too sure why it's running through multiple times. Unless, is there a, yeah, there doesn't seem to be some type of loop here except for this. Oh, right here. Okay. I'm so stupid. Alright, there we go. I didn't see that at the end there. Alright, so our encoder seems to work now. And let's see what we could do for the decoder. I'm gonna delete this. Really, what's the hotkey for deleting? I'm trying to be more comfortable with just using my keyboard so I can be one of those cool keyboard guys, but it's difficult. Alright. Define a fully connected layer with the appropriate number of input channels for the outputs of the encoder. Okay, so let's see actually what the output shape is. Take this, then store this as encode test, right? And then encode test.shape. Shit, alright. Let's just see what it is. Alright. Call maybe length. Wait a minute. 0.shape. Oh, right. Okay, because encode test. Okay. So there's two dimensions, right? The xmu and then x log. I'm not entirely sure what those mean, but let's try to think here. So the decoder then will take in so I think it's 128 by 6,000 something by 2. I think that's what we eventually want. So let's try doing so this is the batch by 6, 7, 2, 8. I'm not entirely sure what this represents by 2. Because you define a fully connected layer with the appropriate number of channels for the app. So self.convolution 2x size 0. All right, let's see here. So we can, I think we could do nn dot conv to actually linear. Okay, so we want a linear activation here. And number of in channels. Is there a features is going to be the latent dimension. Okay. Latent dimensions. So we have, it's 2-dimensional. Oh, okay, so this is the channel here. And then our output should be the converse. Okay, I'm always confused by the upward convolutions. I'm gonna copy these two here. All right. So maybe we want a single channel at the end? Is that what we want? Okay. So in channels, I think we probably want then C, and then we want in channels is equal to C. Oh, wait. I think we might want to do C times 2. Capacity is equal to C plus C is equal to capacity. So not 100% sure what this is. Okay. So we want to do the opposite. It's in channels, out channels. Is equal to C. Right. I wonder if this is the same. I don't think it is, but let's give it a try. Okay, and then let's grab this. Actually, no, we don't need that. So in channels, so this should equal to C, and then the out channels should equal then 1. And we have the same idea here. Okay. Although we don't use, okay, we do use comp2. All right, let's see what happens here. Okay. So let's actually bring everything down to this section. Oops. Okay, I'm gonna clean this up a little bit. So don't need that stuff, right? Test tensor, nope. I'm gonna say we don't need this for now. And then let's do this. Okay, so then let's decode the encode test. Actually, decoder is equal to decoder. All right, and then so decode test is equal to decoder the encode test. This as well. So linear arguments input must be a tensor, not a tuple. Ooh, alright. So maybe we could do this actually. I forgot what the name is, but we could. Instead of setting the tuple equals to a variable, we can break down the tuple into 2 different pieces. Let's try doing that. Let's see what happens. X dot size, huh? What does x dot size 0 do? Curious. So x mu dot shape. Fuck. It is 128 by 720. All right. So I also just want to check. I feel like x bar should be the same thing. Okay, so it's 128 by 2. There's 128 latent vectors. Okay, that makes sense. Now let's try to go to the decode test. So x size dot 0. Print x log var dot size 0. Capacity 28 is valid input. Alright, so maybe then our fully connected layer is not enough. So close in channels, out channels. So batch, think by C. Oh my god. So I think we had previously said that 64 times 7 times 7, this is equal to, nope, what was the dimensions here? So capacity 64 by 64. Okay. If we multiply this by 2, we get 627. Okay, I kind of want to see what x is actually here. So print x dot shape. Okay, what does n in that linear take then? If not channels. Oh, in features, out features. Yeah, okay. I can see the problem here. So this becomes 128 by 128, which I don't think is what we need. I think we might want to do times 7 times 7. So we need to kind of upscale this. There we go. So now it's C B by C by 2 by 7 by 7.
I thought my muscle was spasming. Oh my god.
So this is kind of like the upsampling, I would say. Okay, that's good. Okay, so that's good. I'm gonna do this.
And then they were also trying to convert everything to X the other choice. So then I was like, either something's weird. It could have been possible that there were no correct answers. But then I was like, that's so weird. Like,
Yeah, I think yeah. It's possible. I mean, right?
yeah, I was like, this is possible if this is nominal. Like, I don't think I know this well enough to really say that. So I just chose the way that two of the answer choices, they changed the free variables around, which isn't allowed, right? So I just chose the other two. It was like, those were two I couldn't
Okay,
decide.
so clean some of the code up. So the dimensions are a bit more clear now. Flat tensor, so I think flatten shape to flatten
There was like the fourth one. I don't know, like if it belongs to. I think it does.
everything but the first, the zeroth dimension.
Not outside.
Okay, so this becomes b times c by 7 by 7.
I have to make a slide for a hacker.
And so this is batch by, I think, c by,
He did most of it in lecture and he's making it. Wait a minute.
oh wait,
When you
wait.
do it,
Yeah, when are you getting back? Oh, you're getting verified, right?
20 batch by 2.
I don't know, are you actually getting back like right at 5 or at 4 minutes?
I'll come back like.
So this is the same thing as the latent dimension, right? Yeah.
Yeah, then I'll see you later.
L. So b by L is equal to latent dimension. Here we go. Alright, so this is a lot more clear now, I think, with what the dimensions are for each matrix. Alright, so encoder takes in an image, encodes it into a 128 by 2, or just a b by L vector. And that vector itself represents the latent vector for an image. And then once we have that latent vector, what we'll do is we'll decode it. And this will give us the, I think, actually, let me see what shape this ends up being. I think it should be the exact same shape as a regular input. Okay, I'm going to comment these out. So I'm gonna say these x mu, x log var are latent vectors. Okay. Alright, so let's see what the decode test that shape looks like. I think yeah, that's the exact same size as our input, right? So let's see. Print input dot shape. Yeah, okay. So it just upscales it to the exact same size. Alright. That is a lot more clear now. So we have b by, I want to say 28 by 28 by 1, right? Or by 1 by, okay. So it's one-dimensional. Okay. So that is good. Going to comment all of these out. And then also comment these out. Alright, that's good. Alright. Okay, nice. So now we can move on to exercise 3. Oh shit, this one seems hard. Let's do self dot encoder is equal to encoder, I'd assume. Encoder decoder okay, so I think this is pretty good. So we just have to instantiate a new instance of the encoder and decoder objects for the constructor of our variational autoencoder. And then I think after that, so this is where I am just kind of guessing. I'm not entirely sure what to do here. Whatever works, we'll see if it works, and then if not, then I might have to watch a few YouTube videos or read some stuff. Alright. Latent is equal to self.latent sample. What is self.latent sample? Okay, yeah, I'm not entirely, oh, right here. Okay, the reparameterization trick. Oh, shit. So that's something that I remember we talked about in class during the last five minutes, but at a higher level, it seems like it has to do with running backpropagation through the variational autoencoder. It's a trick because I think what happens is somewhere in the network you have to sample from 2 distributions, and I don't think you can actually run backpropagation through a sampling block or a sampling node, because there is no function there. It's just completely random. So there's this type of trick that you can use to bypass that, but we didn't talk about it, so I'm gonna have to figure that out on my own. But I think what is interesting here, alright, so we could do latent mu latent log var is equal to self dot encoder, and then we'll just pass in x. All right, and then I believe we can just decode our latent vectors so that we have, let's do, okay, oh, so this is our reconstructed, I guess that's what you call it, self dot decoder x, oh, latent, there we go. I'd assume that is what we do. Okay, so haven't done that. Oof, this one seems rough. So VAE loss is a linear combination of the reconstruction loss, computed as binary cross-entropy loss between original and reconstructed image, and the KL divergence. Oh my god. What the hell is that? Between the prior distribution over latent vectors and the distribution estimated by the generated image for the given image. Here we give you the KL term and the combination, but you have to implement the reconstruction loss. Now, KL divergence is another thing I remember talking about, but it just went over my head, so there's going to be a lot of learning here. Of a multivariate Bernoulli distribution P, negative log P of x is the pixel-wise binary cross-entropy. Averaging or not averaging the binary cross-entropy over all pixels here is a subtle detail with big effect on training. Since it changes the weights, we need to pick for the other loss term by several orders of magnitude. Okay. All right. Let me see here. One through 5, 7 through 6, and 10. Okay, hard cap at 100%. All right, I'll take it. So this is probably where I will stop coding, because yeah, I've kind of hit this theoretical roadblock where I have no idea what's going on. So let's go and try to figure out what the hell a variational autoencoder is. Let's do our best. All right. I'm wondering how I should do this. Should I try to watch a YouTube video, or should I just ask ChatGPT to help? Maybe I'll take a look at my notes I wrote to start with, actually. I think I wrote some notes for... Oh, there we go, GAN and VAEs. Alright, so what do I have here? It's So what is a VIE? Didn't even put anything. So you have a prior distribution. I think this is the idea of the probability of some random variable. We'll call it probability of A. I think this is a distribution that is known at the time, because when you have something like your Bayes theorem, probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. So the probability of A, I think, is commonly referred to as a prior, and I think what that means is that you do know this distribution beforehand. I'm not entirely sure, so I'm gonna put that note down as well. But I think what the problem is with VAEs, you're trying to estimate the distribution of your data. That could be the latent vectors. So maybe the distribution of latent vectors. I'm not entirely sure. I think that's a really abstract way to describe it. Maybe a more grounded example could be if you were to, let's say, have a bunch of different faces and you want to represent those faces somehow using numbers, then I think your distribution could be across multiple dimensions. The dimensions being, let's say, one dimension representing whether or not you're a boy or a girl. The other dimension could be like the color of your skin. So these are all maybe factors that would go into how your face would look. And maybe there's a multivariate distribution here. I'm not super familiar with how they work. All right, let me create some notes here. So questions to ask/answer. What is a multivariate distribution? How does it work? And then I wonder if multivariate distribution is the same thing as a joint probability distribution, if they're one and the same. So what is a prior? Do we know it beforehand? What is variational posterior? Okay, KL divergence. What is P and Q? Okay, so these are probably some of the questions I want to answer here, and I think I actually have a saved chat with ChatGPT, right? I might want to pull up my second monitor here. Okay. Alright, nice. I'm gonna move this over. Let's try to blow this up. screen froze on the other end. Yeah, that's not good. Shit. Maybe I have too many applications open. It's causing the memory to shut down. Let's see. Alright, it's better now. That's good. So let's try to see if I have VAs. Nope. Nope. Alright, so it doesn't exist. No. Oh, come on. Oh, maybe I archived it. Settings. Let's see. Archive chats. Alright, yeah. I did archive it. So I did have this here. Alright, let's see. Variational. Implicit density models, on the other hand, define a process to generate Okay, so maybe there's also something called density here that's actually important. Okay, so one thing to note, it seems like with density, is that density only refers to continuous random variables. And I think I remember this maybe from stats. You have two different ways to describe random variable based on whether it's continuous or discrete. If you were to map a discrete random variable to its function, if you were to map a discrete random variable to its probabilities, then you have something called a probability mass function. And then for continuous random variable, I believe it's a probability density function. And so what this is saying is that the density really refers to So this mentions that how dense the probability is surrounding a variable, but I'm not entirely sure what exactly that means. Explain. How totally pack things for space. Context of Like how likely it is to find something in a particular spot. Getting a call real quick. Let me try to answer this. Good work on the two-split roll. You interrupted my stream, by the way. I'm just kidding. There's a whole lot of 0 people watching. Take a walk around. My phone's about to die. And there's no charging port on this table I'm sitting at. Which is kind of unfortunate. Wait, hold on. I'm gonna call you back in a sec. I gotta find a charging place. So my thing is about to die. Yeah.
It's very obvious that it's GCC code. And basically, some people did that when we weren't supposed to. So anyone who did that.
Alright. I'll see ya. Bye. Alright. Thanks for tuning in. Gotta find a new spot for computer, so I'll end the stream for now, but probably start it back up in a few minutes.